You know, we walk around on the surface of this planet every single day. But have you ever really stopped to think about what's happening right under your feet? And I don't mean a few feet down, I mean thousands of miles deep. There's a hidden world down there, a planetary engine that is constantly shaping everything we see and experience. So we're going to dive deep and explore the hidden engine that literally powers our world.
It sounds like a riddle, doesn't it? I mean, what in the world could possibly connect the violent shaking of the ground, a mountain spewing molten rock, and the invisible gas that keeps us all alive? They feel like completely separate, unrelated forces of nature.
But turns out they're not separate at all, not even close. The tsunamis, the earthquakes, the volcanoes you're seeing here, they're all just symptoms. They're symptoms of a much, much larger process happening deep, deep below us. They're all connected to the immense heat and pressure churning away in the Earth's interior. The answer to our riddle is hidden deep inside our own planet. Okay, so why should we even care about what's happening so far beneath the surface? I mean, it's miles and miles away, right? Well, it turns out that studying the Earth's interior isn't just some boring chapter in a geology textbook. It is absolutely critical to understanding our world. I mean, think about it. Peering deep inside our planet helps us understand how our continents and even mountain ranges were formed. It's absolutely key to trying to predict terrifying events like earthquakes. It explains our atmosphere, where we find crucial minerals. And maybe the most important thing of all, it explains the existence of an invisible shield that protects every single living thing on Earth.
And you know what? That shield is so unbelievably important, it really deserves its own moment here. It's probably one of the most incredible secrets that the deep Earth is hiding.
So check this out. The Earth generates its own magnetic field. And no, it's not just for compasses. This thing is a literal force field. It extends far out into space and deflects something called the solar wind, a constant, dangerous stream of charged particles from the sun. Without it, that solar wind would just strip our atmosphere away. Life on Earth, it would be totally impossible.
Okay, so where does this life-saving shield even come from? Well, the source is the movement of molten iron in the Earth's liquid outer core. As this superheated liquid metal rises, cools, and sinks over and over in a process called convection, it creates these massive electrical currents. This whole thing acts like a giant self-sustaining generator, a dynamo, creating our planet's magnetic field. An entire planetary defense system powered by a swirling ball of liquid metal. How cool is that?
And believe it or not, that same internal heat engine does way more than just power our magnetic shield. Its influence reaches all the way up to the very air we're breathing right now. The earliest volcanic eruptions, which were driven by that same internal heat, released gases that were locked inside the planet. And that's what created our atmosphere and the ozone layer that protects us today.
All right, so this all leads to a pretty obvious question, right? If we can't see any of this, how on earth do we know it's there? We can't just drill to the center of the Earth. The heat and pressure are just way too intense.
Yeah, our direct sources of information, things like mining and drilling, they honestly just scratch the surface. It's nothing. So scientists have to become detectives. They have to rely on indirect sources, using powerful natural events to send clues back up to the surface for them to study. And what's their number one tool? Earthquakes. So when an earthquake happens, it releases this incredible amount of energy in the form of seismic waves. And these waves travel all the way through the planet. By studying how these waves behave, where they speed up, slow down, or just stop completely, scientists can create a picture of the Earth's interior. It's like a giant planetary ultrasound. Now, this is where it gets really interesting. There are two main types of waves. You've got P waves, which are like sound waves. They can travel through just about anything, solids, liquids, gas, you name it. But then you have S waves. They're different. They're more like ripples on a pond, and they can only travel through solid material. They cannot pass through liquids. And that right there, that one simple limitation, turns out to be the master key to understanding our entire planet. Seriously, this one simple fact unlocked everything. So what exactly did this master key reveal? All right, let's get to the aha moment, the discovery where this one simple clue allowed us to map the entire unseen world that's right beneath our feet. So scientists noticed that on the other side of the planet from an earthquake, S waves would just vanish. They'd hit a certain depth and disappear, creating a massive shadow zone where no S waves could be detected at all. The only possible explanation?
There had to be a huge layer of liquid deep inside the Earth that was stopping them in their tracks. And just like that, they had found it, the liquid outer core.
And with that one discovery, the entire map of our planet's interior just fell into place. We live on the thin, solid crust. Below that is the mantle, a vast layer of slowly turning rock that actually moves our continents. Then we've got the liquid outer core, which is the engine generating our magnetic field. And at the very center, squeezed by unimaginable pressure into a solid state, is the dense, solid inner core.
So the big thing to take away from all this is that this entire layered system, this beautiful, complex, dynamic engine, is what drives everything. From the ground shaking in an earthquake to the magnetic shield protecting us from space, it all starts deep, deep down. Which leaves us with one final fascinating thought. This whole engine is powered by heat left over from when the planet was first formed. But one day, billions of years from now, it will cool down. So the question is, what happens to our world when its hidden engine finally stops running?